Hello everyone, welcome back to our channel. In today's video, we will be discussing acids and bases, including pH and buffers. Acids are substances that donate hydrogen ions or hydronium ions when dissolved in water, leading to an increase in the concentration of these ions in the solution. Acids are classified as either strong or weak, depending on the extent to which they ionize in water. Strong acids such as hydrochloric acid and sulfuric acid dissociate completely in water, while weak acids such as acetic acid only partially ionize. Acids generally have a sour taste, but it's important to note that not all sour substances are safe to taste, as some acids can be corrosive or toxic. Acids can react with metals, metal oxides, and metal hydroxides to form salts and release hydrogen gas or water, respectively. Acids can also be neutralized by bases, resulting in the formation of water and a salt. The acidity of a solution is commonly measured using the pH scale, which ranges from 0 to 14. A solution with a pH value below 7 is considered acidic. Now, let's talk about bases. Bases are substances that donate hydroxide ions or accept hydrogen ions when dissolved in water, leading to an increase in the concentration of hydroxide ions in the solution. Bases are classified as either strong or weak, depending on the extent to which they ionize in water. Strong bases such as sodium hydroxide dissociate completely in water, while weak bases such as ammonia only partially ionize. Bases generally have a bitter taste. Bases tend to have a slippery or soapy feel when in contact with skin. Bases can also react with acids in a neutralization reaction, resulting in the formation of water and a salt. A solution with a pH value above 7 is considered basic or alkaline, with higher pH values corresponding to higher basicity. The pH scale is a numerical scale used to express the acidity or basicity of a solution. It ranges from 0 to 14, with 7 being neutral, values below 7 indicating acidic solutions, and values above 7 indicating basic solutions. The pH scale is a logarithmic scale based on the concentration of hydrogen ions or hydronium ions in a solution. Since the pH scale is logarithmic, each whole number change in pH represents a 10-fold change in hydronium ion concentration. For example, a solution with a pH of 3 is 10 times more acidic than a solution with a pH of 4 and 100 times more acidic than a solution with a pH of 5. Buffers are solutions that can resist significant changes in pH when small amounts of an acid or a base are added. Buffers are essential in various chemical and biological processes where maintaining a stable pH is crucial. Buffers typically consist of a weak acid and its conjugate base or a weak base and its conjugate acid. The ability of a buffer to resist changes in pH relies on the equilibrium between the weak acid and its conjugate base or the weak base and its conjugate acid. The buffering capacity of a solution depends on the concentrations of the weak acid and its conjugate base or the weak base and its conjugate acid. The greater the concentrations of these components, the stronger the buffering capacity of the solution. Let's take sodium acetate as an example. Acetic acid, also known as ethanoic acid, is a weak acid that can donate a proton to water, producing hydronium ions and acetate ions. This reaction is reversible, meaning that the acetate ions can also react with hydronium ions to form acetic acid and water. When acetic acid and its corresponding salt, sodium acetate, are mixed together, they form a buffer solution that resists changes in pH. The pH of the buffer solution depends on the ratio of acetic acid to acetate ions. Sodium acetate is the salt of acetic acid, and it can dissociate in water to produce sodium ions and acetate ions. If we add a small amount of hydrochloric acid to the buffer solution, the acetate ions will react with the added H+ ions to form more acetic acid, thus preventing a large change in pH. Similarly, if we add a small amount of sodium hydroxide to the buffer solution, the excess OH ions will react with the acetic acid to form more acetate ions, again preventing a large change in pH. Thank you for watching, and we hope you found this video informative. Don't forget to like, comment, and subscribe for more educational videos.